Splicing a number 2 conductor to a 4/0 aluminum conductor to fit a 100 amp main in a mobile home is not considered a tap according to the 2008 National Electrical Code, or NEC. The NEC addresses conductor sizing and protection in Article 310.15 and related sections. It's crucial to understand the requirements for conductor ampacity, which is the current carrying capacity of a conductor expressed in amps. The ampacity must be sufficient for the load it serves and protected against overcurrent. Section 240.4 outlines the requirements for overcurrent protection of conductors. Conductors must be protected at their ampacity, unless specific exceptions apply. When dealing with mobile homes, Article 550 provides specific requirements. Section 550.32 addresses services and feeders. It's important to adhere to these specific requirements for mobile homes to ensure safety and code compliance. In situations where you have an existing 200 amp service and need to connect it to a 100 amp main panel within the mobile home, reducing the conductor size directly at the panel without proper overcurrent protection does not meet the requirements for a tap. A tap, as defined in Article 240.21, allows a smaller conductor to be connected to a larger conductor, provided certain conditions are met. Firstly, the tap conductor must not exceed 10 feet in length if installed in the field or 25 feet in length if installed in a high bay manufacturing facility, which is at least 30 feet high. Secondly, the ampacity of the tap conductor must not be less than the combined calculated loads on the circuit supplied by the tap conductor, and it must not be less than the rating of the overcurrent protective device at the termination of the tap conductors. Thirdly, the tap conductor must be protected from physical damage and enclosed in a raceway or other approved means. Fourthly, the tap cannot supply more than one overcurrent device. In your scenario, simply splicing a number 2 conductor to a 4/2 aluminum conductor without considering these tap rules and overcurrent protection would not be code compliant. The correct approach involves properly protecting the 4/2 aluminum conductor with a 200 amp overcurrent protection device at the source. Then run appropriately sized conductors to a feeder that is adequately protected at the load side. The number 2 conductor would typically be rated for 95 amps at 75 degrees Celsius according to NEC Table 310.16. This means it would require overcurrent protection of not more than 100 amps. To properly connect the 200 amp service to the 100 amp panel, consider using a junction box or a suitable enclosure where you can transition from the 4/0 aluminum conductor to appropriately sized conductors for the 100 amp panel. Install a 100 amp circuit breaker in the junction box to protect the conductors feeding the 100 amp main panel in the mobile home. This method ensures that the conductors are protected at their ampacity and complies with NEC requirements for overcurrent protection. The importance of proper grounding and bonding cannot be overstated. Ensure that the grounding electrode system is correctly installed and connected to the service equipment. This includes a grounding electrode conductor connected to a ground rod, ground plate, or other approved grounding electrode. Bond all metallic parts of the electrical system, including metal conduits, enclosures, and equipment, to create a low impedance path for fault current. This bonding helps to minimize the risk of electric shock and ensures the proper operation of overcurrent protective devices. Article 250 covers grounding and bonding requirements in detail. In mobile home installations, it's also crucial to bond the mobile home chassis to the grounding system. This provides an additional layer of protection against electrical faults. When working with aluminum conductors, always use connectors and terminals that are specifically listed and labeled for use with aluminum. These connectors are designed to provide a reliable and corrosion-resistant connection. Apply an antioxidant compound to the aluminum conductors before making the connection to prevent oxidation and ensure a good electrical connection. Regularly inspect electrical connections, especially those involving aluminum conductors, to check for signs of corrosion or loosening. Over time, aluminum connections can become loose due to thermal expansion and contraction. Tighten any loose connections and reapply antioxidant compound as needed. Use a torque wrench to tighten connections to the manufacturer's specified torque to ensure a secure and reliable connection. Always follow the manufacturer's instructions when installing electrical equipment and making connections. Improper installation can lead to electrical hazards and equipment failure. When working on electrical systems, always de-energize the circuit before starting any work. Use a voltage tester to verify that the circuit is de-energized. Lockout and tagout procedures should be followed to prevent accidental re-energization of the circuit. Wear appropriate personal protective equipment, or PPE, including safety glasses, gloves, and insulated tools. Electrical work can be dangerous, and taking precautions is essential to protect yourself from injury. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. Electrical work should only be performed by qualified individuals who have the knowledge, skills, and experience to do it safely and correctly. Improperly installed electrical systems can pose a serious risk of fire and electric shock. If you are unsure about any aspect of electrical work, consult with a qualified electrician or electrical inspector. They can provide guidance and ensure that the work is done in accordance with the NEC and local electrical codes. Electrical codes and regulations are constantly evolving, so it's important to stay up to date on the latest changes. Attend continuing education courses and read industry publications to stay informed about new technologies and best practices. By following these guidelines and adhering to the NEC, you can ensure that electrical installations are safe, reliable, and code compliant. Remember that electrical safety is everyone's responsibility, and taking precautions is essential to protect yourself and others from electrical hazards. When upgrading electrical service to a mobile home, consider all factors, including conductor sizing, overcurrent protection, grounding, and bonding. Ensure that all work is performed by qualified individuals and in accordance with the NEC and local electrical codes. This approach ensures the safety and reliability of the electrical system and protects the occupants of the mobile home from electrical hazards. Using appropriately sized conductors, providing overcurrent protection, and adhering to the tap rules outlined in the NEC are essential for a safe and code-compliant electrical installation. Consulting with a qualified electrician or electrical inspector can help ensure that all work is performed correctly and in accordance with applicable codes and regulations.